Okay, today I'm going to show you a few examples on converting small decimal numbers to binary. First, we're going to start with 25. Okay, now first you need to find the number of bits you need to represent this. So the formula for that is 2 to the n minus 1, with n being the number of bits that you need. So 2, let's see what would work. 2 to the 3 minus 1, that would be 7, and that does not work. 2 to the 4 minus 1 is 15, that doesn't go up. 2 to the 6 minus 1, 2 to the 5 minus 1 is 31, and that fits. So we're going to need 5 bits to represent 25. So let's see. So we start at 2 to the 4 because remember 0 is going to be our least significant bit at the right, and the leftmost bit is our most significant bit. Remember we start at 0 from the right, and so that is why this is 2 to the 4 and not 2 to the 5, even though we have 5 bits for 25. Alright, so 2 to the 4. Now 2 to the 4 is 16. 16 does fit into 25, plus 2 to the 3, that's 8. That makes 24. We're good so far. Plus 2 to the 2. 24 plus 4 is 28. This is not going to fit into 25. Plus 2 to the 1. 24 plus 2 is 26. So it still doesn't fit. Plus 2 to the 0. Any number to the 0 is 1. So yes, 16 plus 8 plus 1 is 25. So we are now going to write this in binary. And I need my eraser. Alright, in binary, it's going to be 1 for every number that did fit and 0 for every number that didn't. So for 25 in binary, we get 1, 1, 0, 0, 1. Alright, I'm going to do one more example just because I feel like it. Alright, I'm going to do a bigger example. I am going to do 82. So remembering that 2 to the n minus 1 will give us our largest decimal number given from that number of bits. So n is the number of bits that you want. So thinking about 82, how many bits are we going to need to represent 82? Well, let's see. So 2 to the 7 minus 1. That's 127. 2 to the 6 minus 1. 63. Okay, we're going to need 7 bits to represent 82. So we're going to start at 2 to the 6, remembering that you always have a 2 to the 0. So you're starting at 0, and so that means when you have 7 bits, you're really going up to 2 to the 6 because you're starting at 2 to the 0. Alright, so 82 is going to equal, let's see, we're going to start. Yes. We're going to start at 2 to the 6. 2 to the 6 is 64, that does fit into 82. 2 to the 5 is 32, but 64 plus 32 is more than 82, so 2 to the 5 is not going to work. Plus 2 to the 4, 2 to the 4 is 16. And 64 plus 16 is 80. That will work. And now, we're just going to need a 2. So plus 2 to the 3. You don't need an 8. So no. Plus 2 to the 2. We don't need a 4. So no. plus 2 to the 1. That is going to complete our decimal number, but then we still have to do our last one plus 2 is 0, our least significant bit, 1. We don't need that. So 64 plus 16 is 80, plus 2 is 82. So now we can write this in terms of binary. Why do I keep leaving my eraser over there? So all the ones I crossed out are going to be zeros. All of the ones that I kept are going to be ones. So we have 1, 0, 1, 0, 0, 1, 0. So yes, 1, 0, 1, 0, 0, 1, 0. 1, 0, 1, 0, 0, 1, 0 is the binary representation of 82 using the sum of weights method. All right.